Hi, this is the third video in the playlist where we're looking at the Paper 2 calculator for the Edexcel higher tier from the specimen papers set 1. Please do follow the link below in the description, print off the paper and have a go at it before you view the video so you can compare your answers. Okay, hope that's alright. In the last video we got up to question number 18, so we're going to start here with question number 19 that deals with a right angle triangle. And what it tells us is that we've got this sort of dimensions of the right angle triangle in sort of x expressions. I've got x minus 2 and x along here, and it tells us the area is that. Okay, so let's just kind of concentrate on that for a moment, because we're going to use this information to work out the value of x, and therefore we can work out the perimeter. Okay, well, as you're aware, the area of a triangle is going to be base, which is x, times height, which is x minus 2, and that's divided by 2. Okay, half base times height, some people will say, and that's perfectly fine. So I can write it down like that if I want to, and it tells us that the area is 2.5, so that equals 2.5. Okay, so what I need to do now is use this information to be able to figure out my value of x. Okay, well, in order for me to do that, I first need to turn it really into a quadratic formula or something that I can actually work with. So what I'm going to do is I'm going to get rid of this 2 and I'm going to multiply both sides by 2. So if I get rid of that 2 by multiplying by 2, on the left hand side I get x times x minus 2, and on the right hand side I get 5. Okay, then if I multiply out the brackets I get x squared minus 2x. And if I bring that 5 over, I get minus 5 equals 0. So therefore I've got myself a situation now where I've got a quadratic equation that I can try to solve. Now, just looking at it, I can't use trial and error because there's no two factors of 5 that have a difference of 2. So 5 times 1, the only two factors I've got for 5, well, they've got a difference of 4, not a difference of 2. So therefore, it's telling me that I'm going to have to use the quadratic formula. It's also telling me that I have to give my answer correct to 3 sig fig. So I'm assuming there's going to have to be some level of calculation in here. So what I'm going to do is I'm going to say, well, actually, I'm just going to work that out as the quadratic formula, which on some papers you need to remember, on other papers I don't think you do. I think it might be given to you in a formula sheet. But basically I've got then A is going to be 1, B is going to be minus 2, and C is going to be minus 5. Do be careful with these negative numbers flying around the place because they do make it more difficult. So let's have a look at this then. So I've got minus B. Well, at the moment B is minus 2, so minus and minus is a positive, so that's going to be positive. And then I've got B squared. Well, minus 2 squared is going to be 4. Okay. And then I've got minus 4 times A, which is 1, and C, which is minus 5. Okay, and that's all divisible by 2, which is 2 times A. Okay, hopefully that's all right. If you're not sure about quadratic formula, please do some practice. I can't guarantee, but it will turn up fairly frequently on most of these papers, at least on one of the 3 papers that you're going to sit. Okay, so if I pop that into my calculator, be a little bit careful about this. What I'm going to do actually is, before I put it in the calculator, I'm going to just work out this area here, which is called the discriminant actually. So I've got, always doing multiplication first, so I've got minus 4 times 1 is minus 4, and then minus 4 times minus 5 is plus 20. So this becomes 4 plus 20, which is 24, and that's over 2. Okay, pop that into your calculator when you've worked out the discriminant, and you're going to get 2 values of x. One is a positive number, 3.449489 ... It goes on a little bit. You're also going to get a negative number, minus 1.44948 dot dot dot. Okay, well this one I can use because I need a positive value of x. I can't use this one because I can't have a negative value of x. This is only going to be a positive value. Okay, so therefore my value of x, in other words this value along here, is going to be 3.449489, so on. Okay, so I can then use Pythagoras. So what I'm saying is that I've got this Pythagoras here, and on the this side I'm going to leave it as answer minus 2. So if I use my calculator, I've got answer minus 2, and then in here I've got answer, and it just kind of stops me having to plug in all of these numbers in here. Okay, so if I want to do that, I can then just use Pythagoras by saying that this angle here, or this length here, let's call it x. No, we won't, we'll call it y. Okay, otherwise it'd be too confusing, so we're going to call this y. So y squared equals answer minus 2 squared plus answer squared. Okay, so if I want to work out the y value, it's going to be the root of answer minus 2 squared plus answer squared. Okay, and once you've finished running that through your calculator, you should end up with something in the region of this length along here as being 3.74165. Okay, so plug that into a calculator. When you've done that, you then need to add up each of these lengths. So I'll just put that back. So I've got this value of x, which we've said is 3.449489. We've got x minus 2, which is going to be 1.449489. Okay, and then we've got this final value, which is this value here, which is 3.74165. It's a very, very number hungry calculation here, but when you've actually worked all that out, you should get 8.64, and that's to 3 significant figures. Okay, I did debate whether I should actually write all of this down on the video, but it's probably just going to take too long to do that, and I'm sure you'll be able to work that out yourself. Okay, hope that's all right for you. Do take a step or two. If you're not sure about what I've done there, take a step or two just to actually kind of work through that fairly carefully and easily. Okay, let's move on then to question number 20. So question number 20 is one of those questions that deals with gradient. Okay, so we need to just be a little bit careful with this. Because it's gradient of a curve. Okay, so the graph shows the velocity of a parachutist t seconds after leaving a plane. Okay, so in other words, 2 seconds after leaving the plane, he's already travelling at a velocity of 20 meters per second. Okay, and then what it says is work out an estimate for the acceleration of the parachutist at t equals 6 seconds. So in other words, what they want us to do is to find out the velocity, find out the acceleration at that point there. Okay, well that's actually going to be the gradient of the line. Okay, so what I need to do is just write or draw a tangent into here. Now you will be able to print this off and have a look at this for yourself, but obviously in terms of the video it's kind of a little bit tricky to do this particularly well, but hopefully you'll see then that what I can do is I can work out a triangle. Okay, and I just put a triangle into here and just work it out as a gradient. Okay, now it's going to take a few minutes on the video to work out, but I will try to make this relatively straightforward, that I'm looking at the acceleration, okay, and that's going to be the difference in y divided by the difference in x. So it's the same as it used to be, or as it was before for one of the earlier questions. Well, the difference in y is going to be the difference between this point and this point here. So that's the difference between 38 and 55. So at top here I've got 55 minus 38, and at the bottom I've got a difference in x. Well, that's a difference between 4 and 8, so that's actually 4. That's good. I didn't mean to do that quite as well as I did. That's exactly the same as when I worked it out before. That's just pure coincidence. So that's going to give me 4.25 meters per second squared. Now I had a look on the marking scheme for this, and actually it gives you an allowance of somewhere between 4 and 5 meters per second. So don't worry if your result comes out slightly different to mine. That's perfectly fine. It's not a problem at all. Okay, so let's have a look then at part B, and it says work out an estimate for the distance fallen by the parachutist in the first 12 seconds after leaving the plane. Well, really, you need to then work out the area underneath the curve, and it says use 3 strips of equal width. Okay, well, since I've got 12 seconds, then I can divide that into groups of 4. So what it allows me to do is to basically work this out. So I've got effectively strips which I'm then going to use to work out the area by using the formula for the area of a triangle, which is my first one. Okay, and it's just about there. Remember, this is an estimate, so it doesn't have to be fantastically accurate, but it will give you a very good indication. So then I've also got a trapezium, which I'm going to put into, oh, something like about that. I think that'll do it. Okay, so this is going to be A, this is going to be B, and then finally I've got this trapezium at the top here, which is going to be trapezium C. Okay, so this is going to be C. All right, so once I've worked out the area of each of those, what I get then is the total distance that is being fallen by the parachutist. So I've got A. Okay, well, that's going to be a half base times height. Okay, so if I look at that, then I've actually got a half, and base is going to be 4, and then the height in this particular case is going to be 35. Okay, yours might be slightly different, but hopefully you'll get similar results. It is only an estimation. Okay, so let's look then at B. Now in B, I'm going to use the trapezium formula, a half A plus B times H. And again, you might have a slightly different interpretation of the formula, but this is the one that I tend to use. So that's going to be equal to a half. A is going to be, if I just pull this down a little bit, A is actually this length down here. Okay, so this length is A, small a, and then this length here is going to be B. So what we're looking at really is a trapezium on its side. So imagine that we just put it up right, okay? And this here is going to be the value of H, okay? So when you print off, if you have a look at the PDF on the blog post on 3 Minute Maths, you'll be able to have a look at my working for all of this. So I've got 38 plus 54, and that's multiplied by the H of 4. Okay, pop that in your calculator and you're going to get 184, so that's that block B. And then C, I've got the same, I've got a half A plus B times H. Okay, so that's going to be equal to a half, and 51 plus 54 times H of 4 again, and that's going to give me 210. So if I add together this one, and this one, I'm going to get the total distance, which I've worked out as 464 meters. Now again, there is some variation on the mark scheme, so you might get a slightly different answer. It is only an estimate, and it's fine for that. Either way, it's an awful long way to fall, and hopefully the guy's parachute worked okay. All right, so let's move on then to question number 21. Now question number 21, we're dealing then with this particular formula that they're giving us, and they expect us to put some information into this formula. Okay, so it says the number of bees in a beehive at the start of year N is P. Fine. The number of bees in the beehive the following year is given by that formula. At the start of 2015, so 2015, okay, at the start of 2015, there were 9,500 bees in the beehive. So that's, if you like, that's P1. That's the start point. There's 9,500 bees, okay? And then when it went to the start of 2016, you had this situation. You got P2, and that's going to be equal to, so P2 is made from 1 plus 1, it's the next one along, it's going to be equal to 1.05, and that's P to the value of n, which is this P1 is 9,500, minus 250, okay? Pop that in a calculator and you're going to get 9712.5. And then basically it's a case of just duplicating this information for each of the years. So at the start of 2017, we got P3, and that's going to equal 1.05, and this time rather than writing 9,500 I'm going to write 9712.5 minus 250. Okay, whack that in your calculator, that's going to give you 9935.625 of a B. Okay, but at the moment we're just concerned with the numbers rather than accuracy. So let's have a look then at the start of 2018. Okay, so this is what amounts to 3 years later on, start of 2018. Okay, start of 2018 is what we're looking for, so it's going to be P4, that's going to be 1.05, and again I got 9935.625 minus 250. Pop that in your calculator and you're going to get 10,169.9. Okay, 0.9 of a B is as good as 1 whole B, so that's 10,170 Bs at the beginning of 2018. Okay, hope that's all right for you. It is just a case of applying the formula, but you do need to kind of work things through and just make sure that you're happy with the way that that formula is working out for you, and it's a fairly reasonable answer. Okay, so let's have a look then at question number 22. Now this is a question that deals with bounds. Okay, so I'm going to be a bit careful with bounds. Bounds really just means tolerance, so if you're not sure about what I'm doing, please do have a look at some of the videos on the channel, and that'll give you a bit more information, and there are some examples. The way I normally deal with this is I look at in this particular x, and I say that x has got an upper bound and a lower bound, and I always just work them out anyway, that if 99.7 is correct to one decimal place, the lower bound of that will be 99.65 and the upper bound will be 99.75. Okay, so regardless whether I need it or not, I just kind of work it out. So then I've got y, and I'm going to do the same exercise. I've got lower bound and upper bound, but this time I've got 67 correct to two significant figures, so that's going to be 66.5, okay, because that's the lowest number it can be, so that when I correct it to two significant figures, that 6 is going to become a 7, so it becomes 67, okay. The upper bound that is going to be 67.5, okay. So therefore, if I want to work out the upper bound for D, okay, and this is where you've got to be a little bit careful, what I have is I have the upper bound is going to be D equals the largest amount of x, which is 99.75, divided by the smallest amount of y. This is going to be the biggest number I can get, if you like, which is actually 1.5. Okay, so in this particular question, the value of D, the upper bound for D, will be 1.5. Okay, 3 marks. There is a method of dealing with these. Do take your time as you kind of work your way through them. Hopefully that will give you then some idea. Now we've actually got 2 questions left on this particular paper, so we'll crack on and we'll see if we can finish these 2 questions. So the first one is this one. Now actually, if you look on the website 3 Minute Maths, you'll see there is another paper with another question almost identical to this. It's very, very similar indeed. So it's kind of worthwhile just working your way through these papers, because the questions are beginning to repeat themselves a little bit. Okay, so what we're going to do is find the equation of the tangent at point P. So in other words, what they want us to do is to find the equation of this line along here. Well, in order to do that, the first thing I'm going to do is I'm going to work out the equation of a line which is perpendicular to it. Okay, so what I've got is effectively a little bit of Pythagoras going on here. So I know then that this has gone along 4, it's told me there, so I've got 4. I know also that this has gone up 3, which is this point here, so that's a distance of 3, and I know that the radius of the circle is 5, so it's a perfect Pythagoras triangle. Okay, so I can kind of have a look at that, and that'll give me a little bit of confidence in working through some of the work, because I know it's fairly accurate. Okay, so the first thing I'm going to do is I'm going to find the line OP and the equation of the line OP, which is this one that goes along here. Okay, so I would use the general form is y equals mx plus c, and that's the general form of a straight line on a graph. Okay, so m is the difference in y divided by the difference in x, and again we've used that a few times within this particular paper. Now c in this particular case is the y-intercept, which is actually this bit here. Remember, we're looking at the gradient of, we're looking at the equation of line OP, so c is actually going to be 0. Okay, so if I look then at the difference in y, well, that's the difference between here and here, which is 3, and the difference in x, which is 4. So actually I can write this as y equals 3/4 x, and that's it. If I wanted, I could write 3/4 x plus 0. Okay, so that means then that I've got this line along here, which means that I can use this bit of information to work out the equation of this line by using it's perpendicular. It's called the negative reciprocal, because I can say then that line, if we'll call it yx. Okay, it's this line yx. Okay, now that's going to be, again, the general form is y equals mx plus c. Okay, well, I've got y equals then, now the gradient is the negative reciprocal of that, which is going to be minus 4/3 plus c. Okay, and that's an important principle. You need to remember that the gradients, where they meet as a perpendicular, they are the negative reciprocal. Okay, so I then have a point 4,3 on this line that I can just plug into this equation to work out my value of c. Okay, so I can say then that when x equals 4 and y equals 3, if I pop that information into the equation of this line, I'm going to get 3 equals minus 4/3 times x is 4 plus c. Now, you are dealing a little bit with fractions here, so you just have to be a little bit careful in dealing with them. But if you get a little bit of practice, you should be able to kind of work with fractions fairly comfortably. They are a little bit easier to manipulate than decimals, and certainly as you move off into higher level maths, then you'll be expected to work with fractions probably a little bit more frequently than you would with decimals. Okay, so what I'm going to do is I'm going to add 16/3. What I've done there is I've done minus 4 times 4 is minus 16. So I'm going to pull this over to this side, but rather than writing 3 wholes, I'm going to write that, make that easier on myself, as I'm going to write 16/3 plus, rather than 3 wholes, I'll put 9/3 equals c. So therefore c equals 25/3. Okay, bit of an awkward one to deal with, but basically you've got then the equation of the line is y equals minus 4/3x, and it's plus 25/3, and actually that's the answer to the question. What you could do, it's a bit untidy, is that particular one. What I would do personally is I would multiply both sides through by 3, so I'm going to get 3y equals minus 4x plus 25. I just think that's a little bit neater, a bit nicer way of writing it, but essentially you would still get full marks even if you'd written that one out. Okay, hope that's all right for you. So this is the last but one question. Let's move on to to the last question then of this particular paper. I hope you've managed to get through to this sort of level. If you have, that's really great work and many congratulations. So let's move on to the final one, which is a proof. Don't come up so often, but generally you get algebraic proof as opposed to kind of proving circle theorems and that sort of stuff. But what I'm going to do is I'm actually going to split it up into two triangles, because there's properties of triangles that we know. So what I can say is I've got this one triangle, so BAO, and we'll call it OBA. So in other words, this angle and this angle, I'm going to make those equal to x, okay? That means then that on the other triangle, I've got angle CAO and angle OCA. I'm going to make that equal to y. So this is y and this is y. Okay, so if you like, hopefully you'll be able to see this if you print it off or have a look at it on the screen. But I've got then two triangles and I've got their base triangles as going to be, the base angles is going to be either x's or y's. Okay, so what that means then is that if I want to then work out angle BAC, so this is BAC, so it's this angle here, that's going to be equal to x plus y, okay? And that's kind of important to me, okay? Because what I'm doing is I'm trying to prove that the angle at the edge, BAC, is half of the angle in the middle, which is BOC, or if you like, BOC is twice this. So I should be able to put myself in a position where I can kind of calculate this angle as being double this angle, x plus y. Okay, so that's what we're going to do. So the first thing I'm going to say is that I've got two triangles. I've got AOB, okay, and that's angle then, if I try to get this actually on the video, this is the angle that we're talking about here, okay? So AOB is going to equal to 180 minus 2 times x, okay? Which also means that angle AOC, which is kind of opposite it, okay, is going to be equal to 180 minus 2y, okay? So I've now got a position where if I look at this middle area here, I've got an angle here which is 180 minus 2x, an angle here which is 180 minus 2y. I also know that the angles around a point, or the angles in a circle, are going to be 360 degrees. So it's going to allow me to work out BOC, which is kind of what I'm interested in, because that's what I've been asked in the particular question. So BOC is going to be equal to 360 minus AOB, which is 180 minus 2x, and minus 180 minus 2y, which is AOC. Okay, and then it's really just a case of manipulating this until we get to the point where we're able to just make it look a little bit more in keeping with what we're looking for. So if I take out these brackets, I've got minus 180. Now be careful, I've got minus 180 and minus 2x is plus 2x, okay? Then minus 180, and then minus times a minus is a plus 2y. And I don't know if you can see this, but it means then I've got 360 minus 180, so all of this is going to go. And I'm going to get left with 2x plus 2y, okay? So if I factorise that, I can put therefore BOC equals 2 times x plus y, okay, which is twice BAC. Okay, hopefully that's okay for you for twice BAC, which is x plus y. Okay, hopefully that's all right for you. Took a little bit of time perhaps towards the end to deal with that particular question, but it is a 4-mark question, so it's going to take a little bit of time to work through. That's 30 minutes into the video. If you've got this far in it, many congratulations, that's really good. If you've got any questions, please do add a comment below. I'll always come back to you. Please subscribe to the site, and I'll look forward to seeing you inside the next video.